5 examples from the Algebra worksheet. And before we start on them, I'd like to look at two things. The first is our SADMIB. SADMIB is the inverse of BIMDAS, and BIMDAS is how we solve equations. We go this way in BIMDAS, where we have brackets, indices, multiplication, division, addition, and subtraction. In SADMIB, when we rearrange equations, we go through subtraction and addition first, then division and multiplication, and then indices, and brackets. So we can remove this. Next, what do we have? Well, we have our first step, which is invert the operation. So minus becomes plus, multiplication becomes division, and vice versa. 2, we make sure to keep the same number. And step 3, we simplify. With these rules in mind, let's look at example number 1. We have 3, 1 plus x equals 18. What does this mean? 3 immediately next to the brackets. Well, we can also see there's a little hidden multiplication sign in there. Because we have brackets, they are the last thing we're going to look at with SADMIB. Anything inside the brackets is out of the question at the moment. 3 is the only one outside. So let's look at 3. 3 is currently a multiplier of our x value. And because 3 is a multiplier, we firstly invert the operation. So we rewrite the equation. So this is the equation we start with. We rewrite it and we apply whatever we need to apply. 3 is multiplying this, so let's do a division by 3. We keep the same number. And we do this to both sides. Both sides. Divide by 3. Okay, so what can we do to simplify this? Well, 3 times something divided by 3 is just that something. We can cancel these out. 18 divided by 3 is 6. So 1 plus x, we can keep these brackets, equals 6. We can see that these brackets encompass the whole expression on this side. This is one expression. This is another expression. This whole thing is an equation. So this expression is encompassed by the brackets, the whole thing, which means that the brackets don't really have a use. We can also write it as 1 plus x equals 6. Now 1 is being added to the x. There are no other numbers on this side of the expression. So 1 is being added to x. Let's invert the 1, and the inverse of 1 is negative 1, and add that to both sides. So 1 plus x plus negative 1, we're adding the inverse, equals 6 plus negative 1. Whenever we add a negative, we can just say we're taking it away. So I'll just simplify this. 1, take 1. 6, take 1. Therefore, 1, and we can rearrange this. This can be rearranged. And this is one of the laws that we were studying, commutative, associative, and a third one. We have 1 plus x take 1 can also be written as x plus 1 take 1, or 1 take 1 plus x. Now, this is 0. This is 0. They're the same thing. Therefore, these two equal 0, and all of these are equal to just x. So we simplify this. 1 plus something take 1, cancels out the 1s, equals 5. That's example number 1. Example number 2. We have 7, 2x plus 3, take 3, 2x plus 1 equals 10. We need to expand these first. Expanding 7 into both of these is 7 times 2x plus 7 times 3. And expanding 3 into both of them, but it's not just 3, it is negative 3. So we add negative 3 times 2x is negative 6x, plus negative 3 times positive 1 is negative 3, equals 10. We haven't done any rearranging at the moment. We don't need to do anything to this side. Let's simplify. 7 times 2x is 14x, 7 times 3 is 21, plus minus just becomes minus, 6x is 6x, plus minus just becomes minus, plus take 3. And that is still equal to 10. Let's group like values together. 14x, and we take, so 14 has a positive in front of it, but it's hidden. 6 has a minus in front of it, so we have negative 6x plus 21, take 3 equals 10. We're just making this easier to work with. 14x takes 6x. Well, if I have 14 x's and I take 6 of those away, I now have 8 x's. And if I have 21 of something and I take away 3, I now have 18 of that value. 10. Now we are at a very similar stage to what we had here. In this expression, we have our coefficient of x, which is 8. We don't touch that if there's anything else to do. That's our last value that we're actually manipulating. Our negative 18 needs to be changed. So negating negative 18 becomes positive 18. So we go negative 18 plus 18, and we add it to both sides. 10 plus 18. Let's simplify. Well, take 18 plus 18 is just 0. We have 8x, and 10 plus 18 is 28. Now our coefficient, 8 is being multiplied into x, or x is being multiplied by 8. So a multiplication of 8, the negation of that, or an inverse of that, is division. So we have 8x divided by 8, and we do that to both sides to keep the equivalency. And now these can cancel out, so we have x here. 28 divided by 8 is not a whole number. It's not 1, 2, 3, or 4. So we're going to remain with a fraction. However, we're going to simplify it. What is the highest common factor? Well, 8 has the factors of 1, 2, 4, and 8. And 28 has the factors of 1, 2, 4, and 7. 4 is our highest common factor. So let's divide both by 4. 8 divided by 4 is 2. 28 divided by 4 is 7. This is our answer. Let's look at the next example. We have x divided by 7 equals 6 over 21. X is being divided by 7, and therefore we want to negate that. What is the negation of divided by 7? It is multiplied by 7. So let's multiply both sides by this 7. X divided by 7 times 7 equals 6 over 21 times 7. Now, whenever you have a fraction, for example, 1 over 2 times 3, this can go straight into there. What do I mean by that? Well, we can do 1 times 3 over 2. So let's apply this same method into this equation. X times 7 over 7, x times 7 over 7 equals 6 times 7 over 21. What else can we do? Well, let's simplify it. 7 times 7 and then divide by 7 cancel each other out, so we just have x left. 6 times 7 is 42 over 21. 42 over 21. Can that be simplified any further? Well, let's write that down first. I know that 21 is divisible by 7, which is great for me. I also know that 42 is divisible by 7 because we got there by multiplying by 7. So let's divide both by 7. X equals 6 over 3. Well, this makes life really easy, because 6 over 3, we know that 6 over 3 is indeed 2. All right, what about the next example? X divided by 2, take 2x take 1 over 5 equals 2. Now, to make life easy, we want to have the same one denominator and one numerator in an expression. How do we get both of these to equal the same thing? Well, if I have a fraction that is a half, so this is 0.5 or half, to maintain this half, I can multiply both top and bottom by any number. If I multiply it by 10, 10 over 10, I will have 10 over 20, which is still a half, and now I've changed the denominator. When we do this, we need to look at the lowest common multiple, the LCM. The lowest common multiple of 2 and 5 is 10. So how do I get to 10 here? I need to get my denominator to 10. I multiply it by 5. And remember, when I try to get something larger, I multiply both top and bottom. So I have x over 2 times 5 over 5, which equals 5x over 10. So thankfully, that deals with this side of the expression. This side of the expression also needs to have the denominator of 10. How do I get from 5 to 10? I multiply by 2. So 2x take 1 over 5, and we'll do that as a negative, times 2 over 2 is equal to 2 times 2x take 1 over 10. Now we've got the same denominator in both of these, so let's rewrite it. We've got 5x over 10. We take away, that's a negative, we take away 2. 2x take 1 over 10 equals 2. Now that we've got the same denominator, we can combine them. So we can have 5x take 2, 2x take 1, over, all over 10 equals 2. Our next step is then, as we've discovered before, the numerator is effectively in brackets. It cannot be touched. We have to look at the denominator first. This whole expression is divided by 10. The inverse of that is multiplication by 10. 5x take 2, 2x take 1, times 10, divided by 10, equals, and we do the same to both sides, the 10 gets cancelled out, and let's simplify that, equals 20. Okay, now we have two x values. This is interesting, we'll touch on that in a bit. Let's expand this first. 5x, take 2 times 2x. If I have two lots of 2x, I now have 4 x's. And if I have minus 2 lots of minus 1, I have a positive 2. And negation is touched on in the worksheet, is equal to 20. Let's combine what we can combine. Well, 5x take 4x is, if I have 5 lots of something and I take 4 away, I now have only 1 lot of that item, plus 2 equals 20. Now we have no coefficient on this x, which is great. We can look at this constant. The inverse of 2, if we negate 2 from this side, we need to invert it. The inverse of positive 2 is negative 2. X plus 2 take 2 equals 20 take 2. And these can cancel out. We get x, and 20 take 2 is 18. That is our solution for example 4. Now example 5 is a bit more challenging. We've got 4x over 3. X is our coefficient here, 3 is the denominator, plus 3 over 4 equals negative x over 6. The very first thing I would like to do is get everything on the same side. And by everything, I mean all of the pronumerals. Our pronumerals are, this is one fraction with it. This is another fraction. How do I get minus x over 6 to the other side? Well, if this was minus 1, I would add 1 to both sides. But because it's minus x over 6, I need to add minus x over 6. So let's do that. Let's add 4x over 3 plus 3 over 4 plus x over 6 equals minus x over 6 plus x over 6. When you add something and you subtract something, and it's the same something, it's the same value, you get 0. So this will equal 0. Now I'm going to rearrange these so they're just close to each other. X over 6 plus 3 over 4. We don't need this 3 over 4 here. We can negate it to the other side because that's a constant. And in the same step, I'm going to double this because our denominator needs to be the same. So 4x over 3 times 2 over 2. So that will just be this same value, but the denominator can then be added to that, 2x over 6. And we'll do plus 3 over 4. Take 3 over 4 because it's a constant, equals 0. Take 3 over 4. Let's simplify. 4x times 2, if I have 2 lots of 4 lots of x, I have 8 lots of x. 2 times 3 is 6, so 8x over 6 plus x over 6 equals negative 3 over 4. 8 lots of something plus 1 lot of it is 9. So 9x over 6 equals 3 over 4, negative 3 over 4. And we're going to go here. Now we have two options. What are our options? The first is to simplify this fraction. However, that's something that we haven't touched on, and I don't want to look at that at the moment. 9 is the coefficient of x. It's the whole expression is being divided by 6. So let's look at our denominator. Let's make sure the denominator moves across. Because it's divided by 6, we multiply by 6. And we also do the same to this side. This cancels out. We have 9x. And then as we looked up, where was it? It was here. Where was it? There we go. This is what I was looking for. When you multiply a fraction by another number, that number multiplies the numerator. So we multiply a fraction by a number, the number multiplies the numerator. So 3 times 6 is 18. This is the same as 6 over 1, and 4 times 1 is 4. Now 18 over 4 can be simplified. Let's simplify that. 18 over 4, let's divide both numbers by 2. We get 9 over 2. 9 times x equals minus 9 divided by 2. X is being multiplied by 9. The inverse of that is to divide the whole expression by 9. So 9x divided by 9, and as a fraction, equals negative 9 over 2 divided by 9. When we divide a fraction, so here we multiply the fraction. The number goes to the top. When we divide a fraction, the number multiplies the bottom. What does that look like? Well, 9's cancel, firstly, equals negative 9 over the number. When we divide the fraction, the number multiplies the bottom. We have 2 times 9. Before we multiply this, before you tell me this is 18, we can actually just cancel the 9's out. What does that mean? Well, if we have 9 over 2 times 9, and we cancel these 9's out, they become 1. They become 1 over 1. And therefore we have 1 over 2 times 1. When we multiply anything by 1, it just becomes itself. And therefore our solution is x equals negative 1 over 2.